Hello everyone, it's quite cold, my hoodie is out, and that is why I need an easy one because my brain is pretty much frozen to do anything harder than this one. So, this question, merge two sorted lists, what does it say? It says that we've been given heads of two sorted linked lists, sorted being the keyword, and we have to merge the two lists into one sorted list. Now, we can't really form a separate list. That's not the best practice. As you can see by this statement over here, the list should be made by splicing it together the nodes from the first two lists. So we have to point the nodes of both the lists towards each other in a way that the two lists merge into one sorted list. All right, and we have to return the head of this sorted list. Now let's understand this question and the approach that I'm going to teach you with the help of an example. So we have the example over here. There are a few key components other than the nodes themselves. Components are firstly, I've made some arrows to help visualize which node of the respective lists are we currently analyzing. Then we have a dummy node. I'll tell you why are we using a dummy node in a second. And then we will track where the current position of our answer is at any given point in time. So in the very beginning, the current node of our answer will point towards the dummy node. Then what we'll do is we'll keep checking while both lists have some elements pending to be processed. We will do some sort of a process. What process? That process consists of a very simple check where we check which element is smallest between the two nodes that we're currently pointing at in the respective lists. Whichever node is smaller, this current node, wherever it is right now, this current tracker, wherever it is right now, it will start pointing towards that particular node which has been found to be smallest of the two. All right, so I'll take an example. We have this dummy node, and between the two lists, the first elements that we have in these two sorted lists is 1. So I say that we can select any element of the two, it's fine. So let's just go with this one, and we say that this dummy node will now point to this node over here. And the other two steps that we have to follow after this are we have to move the pointer of the first list to the node that comes next to it, as this node has been processed. And we then move the current position to this node right here, so that whenever we have to point next, this node will be the one pointing to whichever of this one or this one we choose next. All right. So the next comparison would be between this one right here and this one right here. And as we can see, the second list has the smaller element whose value is 1. So we simply point our current node to this one over here. And just keep in mind that whenever we do make this connection in green, which is our answer, this white one will eventually stop to exist, right? Because we are now pointing to this node instead of the other one. So by default, just assume that the white ones will stop existing once I start pointing uh, to another node using the green arrows. So we have this one over here, and this node has now been processed. So we move its arrow to the second one, and the current node becomes this one over here. I think we get a fair idea on how to solve this now. So just to ease it out for you, let me bring over the algorithm to the screen. All right, that's the algorithm. It is just the written down version of what I just explained. So we'll analyze the rest of the elements by going through this algorithm, which of course we will be implementing in the next video. For this one, we'll stick to the theory. Now, we have elements 2 and 3 in the respective lists. 2 is obviously smaller. So this node, our current node, will point to this one over here, right? Because we checked while both lists have elements remaining, which they do, if the element in list 1 is less than the element in list 2, which is true in this case, we will point the current node to the element found in list 1, the current element that this blue arrow is pointing to. All right, that is what we've done. And after that, we will move the current node forward. It is a linked list, so when I say that we have to move it forward, it can only move forward to the node where it is pointing. So that is where the current node will move. And of course, as I've been explaining, this node has been analyzed, so the list one's current node will move forward. I've not written this down here as it is quite self-explanatory, but we will be taking care of this part as well in the implementation. Okay. Now, while both lists have elements remaining, which they do again, if list one's element is smaller, we point the current node to list one, but list one's element is not smaller. List two's element happens to be smaller. So we will now point the current node to this one over here. Okay. Now we will repeat the process. We will move the current node forward, and this will go over here. Now we still have both elements remaining inside each list, and both of them are equal. So we'll just use this algorithm and go over to list 2 by following the else condition. Although it doesn't really make a difference, this condition can be if L1 is less than or equal to L2. It won't really make a difference. And what we'll do is just repeat the process, point over here, move the current node, and move this one out because this is the last element. So now this arrow will point towards null. We repeat the process while both lists have elements remaining. Now this is not true because this arrow is not pointing towards null. First list has been processed completely. So then we move out of this while loop. We check if elements remain in any of the lists. We point the current node to that list. So to put it very simply, we point over here. And lastly, we just need to return our answer now because there is nothing really left to process, right? And how do we return our answer? As given to us over here, we have to return the head of the merged linked list. Where is the head of this merged linked list? Simply speaking, it is the very first element that we selected, which comes after the dummy node. So we will return the next node that comes after the dummy node. So you would ask, why did you choose the dummy node in the first place? Well, that is to handle an edge case given to us where the lists could be empty. So if the lists are empty, we might face some issues in calculating what to return. If you use a dummy node, it is very simple. We just return null in that case. It is handled automatically then. So our answer would be something like this. It will follow this path over here. And as you can see, this entire list is perfectly sorted, and that is basically our answer. In the next video, we'll be implementing this approach. So stay tuned and follow for more.